Hello everyone. First of all, I want to start the video by explaining why I uploaded this video late. I was sick for about a week, so I couldn't upload it. I want to apologize to Ayşegül teachers for this. Anyway, let's move on to our video. Today we will examine the code in Java that I prepared in advance. Let's start. First of all, we begin by create a new class called listen client full test. This class um, is going to contain our main method, and it will serve as our test program for um, a list class. And think of it like a test bench or a playground where we try out all the features of our list. This is um, standard main method in Java. It's the entry point of our program, meaning this is where our code starts running. Everything we want to test or print out will happen inside this method. Um, Here we create a new list using our custom list class. This string means that this will only hold strings, so we can store things like apple, banana, and cherry. Inside it, we give it the variable name mylist, so we can refer to it throughout our code. Let's continue. We print a message to the console let the user know um, that we were starting to add some items to the list. It just for clarity when reading the output. Let's continue. These three lines are using the add t new entry method of a list. This method adds um, each new item to the end of the list one by one. So first it adds apple, then banana, and finally cherry. Internationally, this method usually just places the elements at the next available index in the internal array and increases the list size by 1. The time complexity of this operation is typically O1 constant time, but if the international array becomes full and needs to resize, then the operation can take O(n) time because the array must be copied into a bigger one. Let's continue. Um, Here we call in a helper method called printlist that we will define later. This method will go through each item in the list and print it out in order. It's helpful for visually verifying that our operations worked as expected. This line prints a message explaining our next test, inserting the item date at position 2 in the list. In most list implementations, the index starts at 1, not 0. It's important. So this means date will be inserted between apple and banana. Let's continue. My list at this line uses the overloaded version of add, which allow us to specify a position. So my list at to date and inserts dates at position 2, shifting all the elements from that position onward one step to the right. The time complexity is O(n) because of this shifting. We print list again to confirm that date was correctly inserted into the second position. 3. Now we test the get entry in position method. This line retrieves the item at position 3 in the list and prints it. If everything is working correctly, this should be banana because date was inserted earlier at position 2, pushing banana to position 3. The time complexity is O(1). Very efficient because it's just reads from the array. Let's continue. This line test the contains t and entry method, which checks if cherry is somewhere in the list. If it is, it will return true, but otherwise false. This is a linear search, so the time complexity is O(n). Let's continue. Mango, similar to previous line, but this time we are checking for an item that doesn't exist in the list, mango. This helps verify that contains returns false when appropriate. Let's continue. We now test the remove and position method. First, we will tell the user that we are about to remove the first element in the list. This line actually removes the item at position 1 and stores the removed value in a variable named removed. Internally, all the elements after position 1 will shift left by one spot. Time complexity here it's O(n) because of the shifting. Says out. We print out the value that was removed just to confirm what got deleted, and again we print the entire list to make sure the change is reflected. Um, Elderberry, this line performed the actual replacement. It directly updates the internal array at the given index. The complexity is O1. We print list again. um, Say if the replacement was successful. Um, my list. This is where we actually remove everything from the list internationally. This may reset the size to 0 or null out all array elements. Time complexity is usually O1. We confirm the list has been um, there and check if the empty returns true now. Finally, we print the list one last time, which should now be empty. Uh, let's look output. Let's run. Apple, banana, and cherry. Apple date, banana, and cherry. Adding date, position 2. Thanks for watching, guys. See you in other videos.